Hello, my friends. Today we have a lesson in astronomy. We're going to learn about planetary orbits and how the orbits of the planets, as they revolve around the sun, how these orbits of the planets create beautiful patterns. And these patterns are sometimes referred to as planet mandalas. So we're going to learn how complex patterns are created from the orbits of the planets. The orbits of the planets are a natural process. It's part of nature. And it's an iterative process in the sense that it repeats. Iterative means repeating, basically. So the planets go round and round the sun. And so this natural iterative process that creates beautiful patterns has some similarity to the concept of fractals. This is what we'll be covering in this lesson. Now, you may be an astronomer, and you may be an advanced astronomer, and you may be thinking to yourself, what is this guy talking about? Planet mandalas, beautiful patterns. This is something that is sort of fallen between the cracks. You may be an astronomer, you may be in whatever area you're in, and this may be new to you, or maybe not. But anyway, it's a new area of understanding and investigation. Okay, now iterative process. A big breakthrough in mathematics and science in recent decades is the power of a simple iterative process to create complexity. For example, fractal images, and I'm sure you're familiar with the fractal images. They're astoundingly beautiful sometimes. They're created by a simple iterative process. And what happens with the fractal images is that there's a simple formula, and that formula is repeated, and the results from the formula are fed back into the formula, and then based on the results, a decision is made to create these images. So this idea that we can do a simple looping process, repeating something, and produce complex results is a fairly new idea in terms of the history of science. So complexity and repeating patterns at different sizes. So what you find out with fractals is you see as you zoom in or zoom out, you see the image repeated over and over again. And there's some similarity we'll see with what happens with planetary orbits. Not so much in repeating patterns, but the fact that a beautiful pattern, a complex pattern, is created from a simple process of just an object going around in an ellipse. And actually there is some repetition or variation of a theme, you might say, in these patterns. So, orbits of the planets. The planets orbit around the sun, or whatever star they happen to be going around. In our solar system, we refer to that star as the sun, in a seemingly boring elliptical motion. So, for example, I've got a little image here from a website. Where do I have it here? Here it is. Of the solar system, you're all familiar with this. Here's the sun in the middle, and there's little tiny rings very close to the sun are Mercury, Venus, Earth, and Mars, and then further out is Jupiter, and then Saturn, Uranus, and Neptune. And here's Pluto. This isn't the fanciest diagram in the world, but they're showing in this image that Pluto is inclined to the plane of the rest of the planets. It has a greater inclination, about 17 degrees. It's coming up here, going down over there, is what they're trying to show. But anyway, you see, the solar system and the planets just going round and round and round, and you may say, what intricate image is going to come out of that? All I'm going to see are these ellipses. So, in a minute, I will show you. Let me go back to my presentation here. So how are we going to get these images that I'm talking about that are more intricate? By the way, that little solar system was taken from this website, 9planets.org. I just happened to find that as I Googled around for it. Now, before I start explaining the details of how the planet mandalas are created, let's talk a little bit more, just very briefly, about these iterative processes. The fractal images are created by a simple iterative process. And the fractals are not just pretty; they've been found to be useful. They're used in science to understand various behaviors, and this often happens in mathematics. A formula is discovered or developed. It may just be a pure intellectual development, and then later on, someone is able to apply it and find that it's useful. And we may find this with Planet Mandalas. Right now, Planet Mandalas are just beautiful. They're a fact of life that they're created. Whether we can use that information in some practical, applied scientific way remains to be seen. But there's nothing wrong with exploring something just because it's interesting, fascinating, and has its own value just for that. And later on, maybe it can be applied in some practical application or engineering application. Now, this idea of iterative processes creating complexity shows up not only with the study of fractals, but Stephen Wolfram, the great physicist, has a book, A New Kind of Science, where he also emphasizes the power of simple iterative processes in science and their importance. And also patterns. The fact that the iterative process creates a pattern, as we'll see with these planet mandalas, patterns are of extreme fundamental importance in physics. For example, Ray Kurzweil wrote, "My own philosophy is that of a patternist, which one might consider appropriate for a pattern recognition scientist. In my view, the fundamental reality in the world is not stuff, but patterns." And there's the website address of where that's quoted from. So patterns are fundamental. Iterative processes creating complex patterns is right along the conceptual developments, the theoretical developments that are going on in many areas, whether it's the work of Stephen Wolfram or Ray Kurzweil or work in fractals. We see this a repeating theme of how iterative processes create complexity, and we'll see it again in our own solar system with the planet mandalas. So how do the planet orbits become interesting instead of boring ellipses? The first planet mandala, to show you how this happens, was created by Johannes Kepler when he was doing his work to figure out the orbits of the planets. He created what we are now referring to as a planet mandala. Obviously, that's not what he called it. And let me show you from his famous book. Where do I have this now? Okay, over here at this website address, astrosoftware.com/planetmandalas and newscience.htm is a paper. Actually, this is a paper that I wrote. And there it is. This is the diagram from, I believe, the New Astronomy. Yeah, his monumental work, the New Astronomy, is the English translation in 1609. Here's the diagram this is the diagram Kepler made. And this is the motion of Mars. And you may say, what? How is that the motion of Mars? I thought the motion of Mars is an ellipse. Well, this is how Mars appears from the Earth's point of view, from our point of view. So as Mars moves to the other side of the sun, it's moving away from us. And then as it comes closer to us and near us from the sun, it's coming in closer. And so if we plot the position of Mars as seen from the Earth, which is really all you can do if you're on Earth, is imagine that, you come up with this diagram. Now, so that's the image of the actual motion of Mars as seen from the Earth, as Kepler was imagining it would be, that it was moving in closer and further away from the Earth's point of view, while in an elliptical pattern from the sun's point of view. And here, from a modern day computer implementation, is a image. This is a planet mandala for the path of Mars. This is geocentric Mars as plotted by computer software. and looks remarkably like exactly what Johannes Kepler plotted by trying to figure it out. And there's the actual plot for some number of years. I don't have the details of it, but it's plotted for some number of years, and you get the image. So that's what happens. So again, if we go back to that other image of the solar system, this is what the solar system looks like from our point of view, and all the planets moving around. But imagine you're on one of these planets. Suppose you're on Saturn. Well, you're seeing Jupiter as it moves here move away from you, moving, to one side, then coming back, and then making this loop pattern, while Saturn is simultaneously moving, and it starts to create a fairly intricate pattern. So this is what creates the planet mandalas, is looking at these elliptical motions while you yourself are moving in an elliptical motion. And that amazingly creates, well, surprisingly, at least surprising to me, these incredibly intricate patterns. So that's it. The whole point is you're not looking at the solar system like a jolly green giant looking down on the solar system and imagining, this all going around the sun. From the point of view of any object, such as the Earth, which is over here, where we are, as we look at the planets, how are they moving around? So, using modern computer software, here is a plot of Venus, geocentric position of Venus. And amazingly, it creates this 5-petaled pattern. And actually, as you look at it, you'll see here's a loop here, sort of almost a heart shape kind of thing, and then the heart shape is repeated again. It's a very intricate, beautifully balanced pattern, and that is the motion of Venus in the sky. In astronomy, we refer to these as rectangular coordinates. This is taking the rectangular coordinates, the actual position in 3D space of Venus, from our point of view, the geocentric rectangular coordinates, and plotting them. Now, what are the colors? Why is this purple and this red? That is what we would call the z-axis, the height. So we have the 3D space, we have the x and y, and then how far away it is from us, represented by a color. Now, this happens to be Venus plotted. Every day happen to start on January 1st, 1000. That doesn't really matter that much, but it's 2,922 days, where, in other words, Venus might have been, here's the Earth in the middle, Venus might have been here, and then a day later, say it's here, and we draw a line, and then where is it the next day, draw a line to it, draw a line to where it is the next day, draw a line to it, just like we have lines of orbits going around the sun. This is what happens to that elliptical path, as seen from the sun's point of view, now becomes this 5-petaled pattern. It's really amazing. And so again, the colors represent how far away Venus is as we're looking at it from this 3-dimensional perspective, in actual 3-dimensional space. So there it is. That is the motion of Venus. More symmetric, more balanced, more clear and precise than what we saw with Mars. Same idea, but it does create this beautiful pattern. So it's just a fact of life. We're just understanding how the planets move as seen from the Earth's point of view. It just is. Whether we can apply that information in some other way, I don't know, but this is what happens. Now, what happens if I plot it for more days? Instead of stopping at 2,922 days, which happens to be where it meets back and created, this nice picture, what if I do it for a longer time period? And here I told the software, which I'll show you the software in a minute, to make these 5 pixels width so that they're not extremely thin. Now here it's done. Same exact thing, but for 5 times as many days. I think it's 5 times. For 14,610 days, plotted once a day. So it's 14,610 days, 14,610 plots of the position of Venus. And what happens is Venus comes back to where it was after 8 years. In 8 years, it returns back to where it was, but slightly offset. And then when you plot it, it becomes slightly different, and you get this beautiful pattern. Now, what happens? So here it is. In 8 years, this was probably 40 years, whatever 14,610, according to my notes, divided by 365 is probably 8 years. So here it is. That's probably 8 years, 2,922 days. For a longer period, let's plot it for even a longer period. Whoa, is that amazing or what? So now it's plotted for 73,050 days. These are the things we can do with computer software that were not possible before. So the same thing happened with fractals. It was computer software that made fractal theory blossom. Without the computer power, we couldn't see it. We didn't know. And you don't know what will happen to the pattern. I don't know what it's going to look like. I don't think anybody does. You just run it and you see what happens. And the results are startling. Now, do you see what happened here? These bands now continue. And I ran it long enough till they run into each other. And it looks like that. And you end up with these little lippy things coming out. It's just fascinating. And again, the colors are the z-coordinate, the distance from us. This is an untouched photo. This is exactly what the software produces by plotting the positions of Venus. Who would have ever imagined that this would just be the natural result? This is the motion of Venus. It's mind-boggling. What does it mean? I don't know. Maybe it doesn't mean anything. It just is. These are the positions. And somehow this simple fact of life got overlooked. Yeah, it just didn't fall into the academic curriculum or whatever. So now, seems to be the time for becoming aware of how these iterative processes create these beautiful and complex patterns. And this is totally natural. This isn't just a formula made up in someone's head. These are the motions of the planets. So it's fascinating. And here it's run for 14, let's see what I'm reading my notes here, 146,100 days. And you can still see the basic pattern. So let's look at all four of these, one after another, just for fun. Here we see it. More time. By more time, I mean it's been run for more and more numbers of days. So that's it. This is Planet Mandalas. How the orbits of the planets look as seen, not from the sun's point of view, but from some other point of view, such as our point of view. So from the Earth's point of view, that's what the path of Venus looks like. I keep repeating it because it's so simple. It's almost hard to believe that's all it is. That's all it is. Okay, so that's how they become interesting. So I showed those 4 planet mandalas of geocentric Venus. Now there's more you can do with planet mandalas. Once you get this idea that, hey, I can plot the position of a planet in actual space, and I get these patterns, is there anything else I could do? Well, some people got this idea of 2 planet mandalas. Okay, so this is one variation. What we do with a 2 planet mandala is, instead of plotting a single planet, say it's Venus, or Kepler was plotting the position of Mars as seen geocentrically. You plot 2 planets and then draw a line between them. As I wrote here, draw a line between them, and then do the same thing the next day. So just if we go back to this image of the solar system, you can even do this heliocentrically. This is the interesting thing. With the 2 planet mandalas, you get beautiful patterns not only geocentrically, but heliocentrically. So suppose, here's Saturn on this day. I have to suppose, according to this image, Saturn is here, Uranus is here. I would draw a line. Just draw a line, connect them. Now the next day, Saturn will have moved a little, Uranus will have moved, draw another line. So you draw separate lines connecting them, which is kind of what our eye does. When you look up at the night sky and you see 2 stars, you almost visually draw a line between them. So the 2 planet mandala is not a literal image of just where the planet is. It's 2 planets connected, and you get these little line segments, little lines that create sort of usually a radial effect. but then as one planet overtakes the other, they crisscross, and it seems simple, but this is the amazing thing that's been found with fractals, that Stephen Wolfram has found, that a simple formula creates amazing patterns. So you can do two planet patterns. Let me go back to my slideshow here, the PowerPoint. So that's one variation. And here we're doing a little more than nature. We're connecting the planets, sort of a human idea or a mathematical abstraction added to the mandala by drawing a line between them. So that's a variation on planet mandalas. These are all planet mandalas. You can have a simple one planet mandala, a two planet mandala. And another variation is that instead of plotting the actual position of the planet, a variation is you could plot the longitude from 0 to 360 degrees. So if you're doing this geocentrically, for example, you can measure where the planet is in right ascension or zodiac longitude from 0 to 360. You're measuring it around the circle from whatever starting point you use. And then for the distance from the center, use the speed. So it's almost like you're measuring the centrifugal force, like as the planet speeds up, it moves further out. Because the planets change speed slightly from the heliocentric point of view, and from the geocentric point of view, they change dramatically. They can even appear to go backwards, which is sort of an optical illusion. But anyway, you can plot the position around the circle and then distance from the center as the speed, sort of like a radial plot. And that would give an image of kind of the force of the planet if you think its motion sort of represents an increased force. So you get a visual that represents certain functions of what's going on. The interesting thing about a longitude and speed mandala is that you've incorporated the speed or motion of the planet rather than just its position, and it creates interesting patterns. Whether these beautiful patterns have some scientific application or relevance, I don't think anybody knows right now, but you do get beautiful images. Okay, so let's look at some of these images. So I'm in this software called Sirius version 1.3, and I'm in the section of the software for looking at planet mandalas. And this I've selected on the right side. You have selections, and here are the different selections. The geocentric one planet actual position, we understand what that is. That's what Kepler did, and that was the images I showed of Venus are geocentric, a single planet. We could do two planets. That's where they're drawn together and connected. We can do it heliocentrically, two planets, and here are the longitude speed mandalas. The longitude by speed mandala can be done one planet geocentrically, two planets geocentrically, or heliocentrically. So you get the idea. You can do a two planet or a one planet doing actual position. These are the actual rectangular coordinates, or this longitude by speed map, and you just get incredible images. So the one we're looking at now is Venus, similar to what we saw before, geocentrically. Now you just play. Nobody knows what it will look like. You might say, well, gee, which ones look interesting? You just have to look and see what happens, because it's too mind-boggling for the human mind to figure out ahead of time. So let's try geocentric, two planets, actual position, meaning the rectangular coordinates, rather than longitude by speed. And we get an image like this. This is Mercury and Venus. The setting here was show the positions once a day, do 400 calculations. This is only a little over a year. So it's run for a little over a year. Mercury and Venus. And look at the scrolling as the planets change speed and go retrograde, and they're changing speed in relationship to each other. Who would imagine you could get this incredibly beautiful thing? With this software, We even gave names to them. Beautiful bird. It looked like a bird to us when we created it. And then you can just change it. You could say, well, run it for 4,000 days. What'll happen? I don't know. You can just try it. Let's try 1,000 days. And then you say, draw a customized mandala. And when you do this, it analyzes what's going on. Well, you can see what happened. First it did that bird thing, and then added some more stuff onto it. And sometimes it goes through several loops as it analyzes the maximum size that it's reached, the maximum distances, so it knows how to fit it on inside the window. And now it looks like that. And you can just go crazy here. And we've created lots of them that we just randomly picked planets and said, oh, that looks pretty, let's add that to the program. That's really all we did. We just said, this looks cute, let's add that. Or maybe we thought it was educational in some way, like Sun and Mercury created 3 fans like that, 1, 2, 3, over 1 year. So, you can think about why it would do that. I mean, there's just so many. I'll just randomly pick, what is this? Mercury, Venus, 5 petals in fans. So this looks like it's going to calculate once a day for 2,800 iterations. Oh, that's kind of similar to what I just showed you, actually. But running even longer. And look how this shape begins to form in the middle. Interesting. So you get forms that look like things in nature. They're quite fascinating. Let's pick some different planets. Let's do Mercury, Mars, Networking 1. Just names we gave to them. So this looks like it's Mercury and Mars done once a day for 5,000 days, starting on January 1st, 1900. And there's a magnification selection, and we zoomed it in. You can see it was zoomed in. So you can zoom into some part of it. You can also do some adjustments here, horizontal and vertical adjustment for what part you're looking at. Here's that line thickness. Here the thickness is just 1 pixel in order to pick up all of this refinement. And so while I'm talking, you're watching this thing get drawn, and look at these scrolls they look like. Little scrolls on scrolls on scrolls. So who would imagine that this looks like a net with scrolling images? This is the actual motion of the planets. That z-coordinate to give depth, here's the color when the z-coordinate is minimum, and here's maximum. So the light color is far away, the dark color is when it's closer. You get almost a little circular image inside this. Looks like a little trumpet or like a flower, like a stalk of a plant. Amazing. You just create it out of the motions of the planets. So this is Planet Mandalas. They're fascinating. They're wonderful. They can be little, works of art, a merger of science and art. And we can just play and play and play with this stuff. Let's try heliocentric 2 planets. This is Earth and Venus. Now, it's calculated every 5 days, which helps speed it up by not calculating it every day. And that looks similar to the Venus as seen from the Earth. Let's see what other choices we have here. We've got even asteroids like Ceres and Pallas and Wedding Band 5. Who knows? We'll just see what this does. First it plots it in a black color. Those are those little line segments that it's drawing. Then it does it in the actual color. Oh yeah, it looks like a little ring, doesn't it? Jupiter, Saturn, flying balloon. Okay, so these are just the actual motions of the planets. Well, go back to this 10,759 number of days. Oh, this is separated. This, instead of running every day, it's just plotting periodically. So it's jumping 10,759 days for the next position. And it does this only just 90 times. So you don't have to do it each day. You could jump around, and then you'll get more interesting patterns. You're like sampling, periodic sampling of where the positions are. I'm not sure how I got 10,759 for that. It seems like an oddball number. Maybe it's a certain number of years. So anyway, let's look at some more kinds. We've got longitude and speed. Let's do 2 planets, longitude and speed. Look at that. Who would imagine? It looks like sort of like 2 mountain peaks or whatever. What do we call it? Treasure the inner light. Amazing. So this is a plot of the positions of Sun and Jupiter seen geocentrically, with the distance from the center represented by the speed, and how the speed of the planet ends up creating these patterns. It's just absolutely amazing. Absolutely amazing. So there you go. I've pretty much covered this. I think I'll come to a close now. I'm running the... this is the Sirius 1.3 software, which has these options for longitude by speed. That's probably unique to this software. It was an idea that I came up with when I was working with this. I got the basic formulas from a fellow named Mark Pottinger, who was one of the early developers of Planet Mandalas, and he worked with Neil Mickelson on it. And I think the story is they saw a movie about it. I'm not sure who realized it. Probably somebody reading Kepler or something, or somehow realized that the planets make these beautiful patterns. And the idea of the shading for the z-coordinate was something I added to the software. Just occurred to me as something sort of obvious that I could do. And here you pick whatever colors you want for it, and it does a gradient from this color to this. I can click on it and pick what colors I want with the color selection. So you have all these, different variations of the planet mandala that are available. And Stephen Wolfram implemented the idea of the planet mandala in his Mathematica software. You'll see that on his website. And there's probably other software to produce them. So fascinating that the movement of the planets create these beautiful images. Last thing I'm going to say, and we'll wrap this up. No, I don't want to go there. I want to go back to my last slide of my thing. Is this astrology or is it astronomy? Well, it's astronomy. We're describing the positions of the planets. It's just pure astronomy. We're not implying that this has some relevance to our lives. We're just saying this is what is. I think it's fascinating. It's exciting. It's worth exploring. It makes you wonder. They look so lifelike. You see patterns that look biological. They look like plants. They look like mountains. Maybe this is somehow connected to life on Earth. Well, if it is, you could call that a kind of astrology. You're relating what's going on here to what's going on in the sky. From a strict academic scientific point of view, that those kind of relationships, other than through known means like gravity, but these more exotic relationships have not been found yet. So if they are found, this would be a kind of astrology. So it's a kind of thing that Theodore Landscheid with cosmic cybernetics and areas that I work in use forms of relationships of celestial activity with things on Earth using mathematical models and tools like this. And if a relationship is found, then we made a bridge. So I think astronomers should not be afraid of this. Maybe something will lead into it as long as astronomy continues to use good critical thinking skills, analysis, and validation. There's no reason not to grow into new areas that might sound unattractive, like astrology. And for astrology, they also don't need to be afraid that there might be connections and relationships of things on Earth with the sky that are completely outside the domain of what astrologers usually use, a different language, a different set of tools that may shown to be valid and useful. Okay, so there we go. Planet Mandalas, an interesting astronomical fact of life. Just wonderful creative stuff. I'm hoping that more and more people get excited about it. Maybe people in astronomy will start putting planet mandalas in the hallways of the colleges of astronomy. It'd be fascinating to just wake up to this wonderful imaginative reality that's out there. We don't have to just look at the boring ellipses. This is out there. This is what's in the sky. Okay, I hope you enjoyed that. Hope you found that inspiring and motivating to the wonders and beauty of science. Okay, thank you very much. Take care.